Okay, so this is step 3 and 4 of the preparatory phase of glycolysis. So you can see step 3 and 4 are already written here. So after the step 2, you know the fructose 6-phosphate is going to be formed, right? So I already numbered for you here. Notice that, the structure might look a bit different from your textbook or your material, because I want you to see like easier way than normally what the textbook would show you. Alright, so I hope I hope it would be easier for you to understand it. So now step 3 involves turning a fructose 6-phosphate into a fructose 1,6-biphosphate. So you can see that they are trying to gain one more phosphate in there. So what's the enzyme then? That's right, you need a kinase to do the kinetics. So here's the kinase. The kinase enzyme that acting on the fructose molecule that contain phosphate groups. There you go, they name it according to substrate again. They name it according to the substrate that the enzyme will act on. So the enzyme name is phosphor fructose kinase, PFK. And also you want to add a phosphate group, you need ATP there. This is a second ATP usage. Remember? First 5 steps of preparatory phase, you need use up 2 ATP. Use up 2 ATP, okay? So this is a second ATP utilization. And of course, you need environment that contain magnesium ion. Now, it's going to add a phosphate group into this number 1 position. So you can see CH2O, PO3 2 minus here. And as this one comes into number 1 position of carbon, it kicks out the hydrogen, just as usual. So this hydrogen will be here in the environment, no? Of course not. Hydrogen H+ is acidic, and you don't want it to sit in the environment and become deadly or toxic for the cell. So the H+ has to be carried by the NAD. The NAD is called the proton or electron transporter. I don't know why it's named that way, but they just transport the H. So in the textbook, you can see it written like NADH. NADH because they already carry the H+, okay? You will see where they carry to later, I'll tell you. But when the ATP is used up, it becomes ADP. I already explained. Sorry. Maybe I need more glucose. And then step 4 is when you got the fructose 1,6-biphosphate already. Hope I'm not hindering the board. And this is a ring form of that. Phosphor 1,6-biphosphate will have to be split into 2. You can see that they split to 2. But before the splitting, they have to turn into the straight chain form first. Okay, bear with me. Let's go from number 1. There you go, this one, and then the C, number 2, and then there is a ketone groups. Okay, the C number 3, H and the O here. C number 4, H, OH and the H there. C number 5 is this one. Oh, this OH actually comes from this oxygen. And then C number 6 and this one. Okay, so you can see that this enzyme, they do something to change some groups, functional groups in there. The enzyme name is aldolase. The enzyme that will turn the aldehyde and the ol is the OH groups. They can convert between the aldehyde and the OH groups. So what happened here is that this OH group is the ol part will be converted into a ketone part that you see. While at number 5, the O here will be converted into the ol part, which is the OH. Okay. Now, since you have the fructose 1,6-biphosphate straight chain form, the aldolase will do one more thing, which is splitting it in the middle. Split right in the middle. So what you have left here is this dihydroxyacetone phosphate, DHAP, and you have glyceraldehyde 3-phosphate or GAP. So this DHAP will eventually be converted into this GAP in step 5. Okay, because only GAP will be able to continue on with the glycolysis. Now, I'm going to explain further a bit. So here, why is this carbon number 4 turn out to be this one with an aldehyde group? So you can see here, one hydrogen is donated to this carbon number 3 here. So it becomes CH2 here instead of just CH. So when this one donates a H, it's actually undergo oxidation. And oxidation of a hydroxy group becomes, that's right, aldehyde. I think I should remind you that what is oxidation and what's reduction. So oxidation is adding in oxygen or removing hydrogen. So of course reduction will be adding in add a hydrogen and removing oxygen. Okay, so this one will become an aldehyde group and we have it like this. Okay.